children, let's try to figure out some of the nature's mysteries using mathematics. Real mathematics is not crunching numbers, but contemplating them and the mysteries to their connections. This quote of a famous mathematician tells us that mathematics does not just mean adding or subtracting. In broader sense, mathematics is nothing but trying to find the universal laws in the system. Of course, 2 plus 2 is equal to 4 is one of them. You must have observed that in nature, many things follow a certain pattern, such as the petals of sunflower, the holes of a honeycomb, the grains on a maize cob, the spirals on a pineapple and on a pine cone, etc. A nature walk reveals an endless variety of forms. Nature abounds in spectral colors and intricate shapes, such as the rainbow mosaic of butterflies' wings, beautiful flowers, and undulating ripples of sand dunes. These miraculous creations not only delight our imagination, but they also challenge our understanding. How do these patterns form? What rules and guidelines shape the nature around us? We can see that some patterns are molded in strict regularity, such as the hexagonal symmetry of the cells of a honeycomb, equiangular spiral-shaped shells of nautilus, and of course, crystals. In this session, we will talk about how patterns in plants, flowers and animals can be connected to the set of numbers. Many designs in nature are hard to understand but easy to recognize. You can draw a tree or a flower, but can you know why does it look like that? Usually part of the answer is that nature is amazingly clever. The life tends to get the most out of the resources available, and for that it chooses the easiest path. Sometimes we are lucky to get clues about how this works from mathematics. One such case is Fibonacci sequence. We will look at this special pattern and compare it with the patterns found in nature. A sequence is list of numbers which are following a certain rule. For example, 2, 4, 6, 8 is a sequence in which the difference between the two numbers is 2. So, we can get the succeeding number by adding 2 to the preceding number. Let us see the Fibonacci sequence. Fibonacci came up with a rule that has wonderful properties. The idea is this: start from 0 and 1. Make more numbers by adding the previous two numbers together like this. 0 plus 1 is equal to 1, 1 plus 1 is equal to 2, 1 plus 2 is equal to 3, 2 plus 3 is equal to 5, 3 plus 5 is equal to 8, and so on. So, the sequence is 0, 1, 1, 3, 5, 8, 13, 21, 34 and so on. The pattern seems to be nothing but a mathematician's daydream. But for the reasons unknown, nature has incorporated it in its botanical footprints. The pine cones, the pineapple, the sunflower and many more flowers and animals are showing this pattern. For example, the number of spirals on the pine and on the pineapple are Fibonacci numbers, and you can accurately count these spirals. Let us see. You can see here that pine cone shown has 8 clockwise spirals and the 13 counterclockwise spirals. There are many more spirals to count on the sunflower. Fibonacci sequences are also found on the seeds and the arrangement of leaves. Let's look at some patterns in our day-to-day life also. An auditorium has 20 seats on the first row, 24 seats on the second row, 28 seats on the third row, and so on, and it has 30 rows of seats. The number of seats in first, second, third and the 30th row will be respectively 20, 24, 28, 32 and 136. Another example is the cost of plastering a floor for the first square meter is rupees 50 and rises by rupees 5 for each succeeding square meter. The cost in rupees for plastering first, second, third and so on square meter will be respectively 50, 55, 60 and so on. Let's take another example where a rumor spreads in such a way that every minute a person passes on the news to two different persons. The number of persons to whom the news spreads after first, second, third and so on minutes will be respectively 1, 2, 4, 8, 16 and so on. Let's take an example of depositing money in the bank. You are aware that when we deposit money in the bank, we get interest. So let's take one example. A sum of rupees 1000 is invested at 8% simple interest per annum. The interest in rupees at the end of first, second, third and so on years will be respectively rupees 80, rupees 160, rupees 240, rupees 320 and so on. Another example is a pair of rabbits is too young to produce in their first month. In second month and every subsequent month, they produce a new pair. Each new pair of rabbits produce a new pair in their second month and in every subsequent month. Assuming no rabbit dies, the number of pairs of rabbits at the start of the first, second, third and so on months respectively are 1, 1, 2, 3, 5, 8 and so on. Let's understand it pictorially. Do you remember? This is the famous Fibonacci sequence. Numbers can also have interesting patterns. Can you recall natural numbers, odd numbers and even numbers? Yes, they are also forming patterns. In natural numbers, each succeeding number is obtained by adding 1 to the preceding number. And in case of even and odd numbers, each succeeding number is obtained by adding 2 to the preceding number. Let's see few more examples of patterns in numbers. 3, 9, 27, 81, 243, 729, 2187. This number pattern has a factor of 3 between each number. The pattern is continued by multiplying the last number by 3 each times. Now, here is another list of numbers 1, 3, 6, 10, 15, 21, 28, 36 and 45. This number pattern is generated from a pattern of dots which form a triangle like this. By adding another row of dots and counting all the dots, we can find the next number of the sequence. So, here you can see a picture where these numbers are arranged in triangle form. That is why these numbers are called triangular numbers. Another important list of numbers which you are already aware of is 1, 4, 9, 16 and so on. What are these numbers? These are square numbers. The next number is made by squaring where it is in the pattern. The second number is 2 squared. The third number is 3 squared and so on. Here is another pattern. These are cubic numbers. The next number is made by cubing where it is in the pattern. The second number is 2 cubed. The seventh number is 7th cube and so on. In these examples, we observe some patterns. So, we can say that a number pattern in a definite order following a certain rule is called a sequence. You must be wondering, why am I talking about patterns and sequences? Sequences and patterns have important role in our lives. These are used in biotechnology, astronomy and textile designing. DNA and nucleotide chains form beautiful patterns. The clothes you are wearing, the design on them also is following a beautiful pattern. So, that is why sequences are important to know. In the above sequences mentioned, we have found that in some sequences we can obtain the succeeding number by addition of a constant number. In other, we have to multiply it by some number, or in the next we have to square it. But today we are going to restrict ourselves to the sequences where we are getting the succeeding number by adding a constant term to the preceding number. Such types of sequences are called arithmetic progression. Let us consider a few arithmetic progressions. Here we are given a list of numbers 1, 2, 3, 4, 3, 3, 3, 3 and so on. Each of the number in the list is called a term. Given a term, can we write the next term in each of the list? Yes. How can we do that? By observing the pattern and finding the rule. Let us see in these sequences what is the rule. In 1, each term is 1 more than the term preceding it. In second pattern, all the terms in the list are 3, that is each term is obtained by adding or subtracting 0 from it. In third case, each term is 1 more than the term preceding it. In fourth, each term is obtained by subtracting rupees 50 from the preceding term. And in fifth case, we have to add 50 to get the succeeding term. In the last case, each term is obtained by adding 1 to the term preceding it. In all the examples shown here, we observed two important features. The numbers are following a definite order and every list starts with an arbitrarily selected number. The successive terms are obtained by adding a fixed number to the preceding term. We observe that in lists 1, 2, 3, 4, 5 and 6, the fixed quantities are 1, 0, 1, minus 50, 50 and 1 respectively. This fixed number is called the common difference of an AP, and we can see that it can be positive, negative or 0. So, each of the list is said to be in AP, and we can say that an arithmetic progression is a sequence of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So, to check whether a given sequence is an AP or not, we have to find this fixed term. How can we find this fixed term? Of course, by subtracting the two consecutive terms. If this difference is same, we call it a common difference. So, if we have an AP with the first term A1, second term A2, third term A3 and nth term AN, then it can be written as A1, A2, A3 and so on up to AN. So, the difference between the two consecutive terms can be explained as A2 minus A1, A3 minus A2 and so on. Now, if this difference is same, then we say that this is an AP and it is named as D, the common difference. So, we can say that A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 and so on, and that is equal to D, the common difference of the AP. So, we can find the fixed term by finding the difference between the two consecutive terms, and we can check whether a given sequence is an AP or not. Let us once again consider example number 1 to 6. Note that sequences 3, 4 and 5 have fixed number of terms. So, the sequences are called finite AP because they have a last term, whereas sequences 1, 2 and 6 have no last term. So, that is why they are called infinite APs. So, in this session we started our journey with patterns in nature and we have reached till AP junction. Let us recapitulate. A number pattern in a definite order following a certain rule is called a sequence. An arithmetic progression is a sequence of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. The arbitrary term chosen to start an AP is called the first term and is denoted as A. The fixed number added to each succeeding term is called the common difference of an AP and it is denoted by D. And here are few situations for you for which you have to obtain a list of numbers in each case and then find out whether they are in AP or not. So, be ready with your papers and pencils and note down. Amount left with Sandeep in rupees out of the total amount of rupees 12,000 which he had in the beginning when he spends rupees 500 at the beginning of every month. Number of students left in the school auditorium from the total strength of 1000 students when they leave the auditorium in batches of 25. The amount of the money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. I hope you know how to calculate compound interest. This you have done already in class 8. A rumor spreads in such a way that every minute a person passes on the news to two different persons. The number of persons to whom the news spreads after every minute. In the next session, continuing our journey, we will reach a destination where we will see the pictorial representation of sequences to understand the concept of AP in a better way. For that, be ready with 3-4 graph papers, glue stick, colored pencils, sketch pens, etc. So, till then, have a nice time. Goodbye. Hello children, once again welcome to AP Express. It means Arithmetic Progression Express, not Andhra Pradesh Express. Hope all of you are ready with the pictorial representations of the sequences given to you last time. Which one of them is an AP? The first sequence given to you was 2, 2.5, 3, 3.5 and so on. And the second sequence was 1, 2, 4, 8, 16 and so on. Here, match your representation with my representation. Did you represent it correctly? You can observe here that first sequence is an AP whereas second sequence is not, because the difference between the two adjoining steps of the ladder so formed is same in the first case, that is 0.5, whereas it is not same in the second case. Now, after pictorial representation, our next destinations are general form and nth term of an AP. But before we start our journey further, let's recall the important destinations of our journey so far. An arithmetic progression is a sequence of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. We can represent a given sequence pictorially. If the given sequence is an AP, a ladder is formed in which the difference between the heights of adjoining steps is constant. The arbitrary term chosen to start an AP is called the first term and is denoted as A. The fixed number added to each of the succeeding terms is called the common difference of the AP and is denoted by D. Now, let's proceed to our next destination. Here is an arithmetic sequence 7, 14, 21, 28 and so on. What is the first term of this AP? Yes, it is 7. What is the common difference? It is 7 again. As you can see that there is a difference of 7 between the two consecutive terms. So, we can write the AP as 7, 7 plus 7, 7 plus 7 plus 7, 7 plus 7 plus 7 plus 7 and so on, which can be written as 7, 7 plus 1 into 7, 7 plus 2 into 7, 7 plus 3 into 7 and so on. Here is another sequence 15, 10, 5, 0, minus 5 and so on. Here you can see that first term is 15 and the common difference is minus 5. So, we can write the arithmetic progression as 15, 15 plus minus 5, 15 plus minus 5 plus minus 5, 15 plus minus 5 plus minus 5 plus minus 5 and so on, which can be written as 15, 15 plus 1 into minus 5, 15 plus 2 into minus 5, 15 plus 3 into minus 5 and so on. Let's consider an AP whose first term is A and common difference is D. So, we can write this AP as A plus D, A plus D plus D, A plus D plus D plus D and so on, which can be written as A plus D, A plus 2D, A plus 3D and so on. This is called the general form of an AP. With the help of general form of an AP, we can determine the AP. Now, to know about an AP, what is the minimum information that we need? Is it enough to know the first term or the common difference? Suppose you are to find an AP with first term say 4. Can you find it? No, as we don't know what fixed number to be added. Similarly, we cannot find an AP with the common difference only, as we don't know from where to start. So, to find an AP, we need both the common difference D and the first term A. For instance, if first term A is 4, common difference D is 3, then the required AP is 4, 4 plus 3, 4 plus 2 into 3, 4 plus 3 into 3 and so on, which can be written as 4, 7, 10, 13 and so on. And if A is equal to 6 and D is equal to minus 3, then what will be the AP? Yes, you are right. It is 6, 6 plus minus 3, 6 plus 2 into minus 3, 6 plus 3 into minus 3 and so on, which can be written as 6, 3, 0, minus 3, minus 6 and so on. Similarly, when A is equal to minus 7 and D is equal to minus 2, then AP is minus 7, minus 9, minus 11, minus 13 and so on. And if A is equal to 2 and D is equal to 0, then AP is 2, 2, 2, 2 and so on. So, you can see that D can be positive, negative or even 0. So, by knowing A and D, we can find an AP. What about the other way round? That is, if we are given a list of numbers, can we say it is an AP? Can we find A and D? Yes, we can do that by subtracting any two consecutive terms. In general, for an AP A1, A2, A3, A4 up to AN, we have D is equal to AK plus 1 minus AK, where AK plus 1 and AK are K plus 1th term and Kth term respectively. Let's make this concept more clear with the help of few examples. Here is the first example. For the AP 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2 and so on, write the first term A and the common difference D. Here A is equal to 3 by 2. And what is D? Yes, D is equal to A2 minus A1 and that is equal to A3 minus A2 and so on. So, D is equal to 1 by 2 minus 3 by 2 and that is equal to minus 1. Here is the second example. Which of the following list of numbers does not form an AP? If they form an AP, write the next two terms. The first is 6, 10, 16, 22 and so on, and the second sequence is 1, minus 1, minus 3, minus 5 and so on. Let's consider the first sequence. What is the first term in the first sequence? Yes, it is 6. Let's check whether A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 or not. A2 minus A1 is equal to 10 minus 6 and that is equal to 4. A3 minus A2 is equal to 16 minus 10 and that is equal to 6. A4 minus A3 is equal to 22 minus 16 and that is equal to 6. So, we can see here that A2 minus A1 is not equal to A3 minus A2, which is equal to A4 minus A3. Therefore, it is not an AP. Let's take the second sequence, which is 1, minus 1, minus 3, minus 5 and so on. Here, A is equal to 1. Now, A2 minus A1 is equal to minus 1 minus 1 and that is minus 2. Let's check A3 minus A2. A3 minus A2 is equal to minus 3 minus of minus 1 and that makes it minus 3 plus 1, which is again equal to minus 2. A4 minus A3 is equal to minus 5 minus minus 3, that makes it minus 5 plus 3 and again we get minus 2 as answer. So, we can see that A2 minus A1 is equal to A3 minus A2 and that is equal to A4 minus A3. So, is it an AP? Yes, because the difference between two consecutive terms is constant. So, a list of numbers is an AP if the difference between two consecutive terms is same. As you have observed that the general form of an AP is A plus D, A plus 2D, A plus 3D and so on. Let's now explore the nth term of an AP. Let's consider a situation where your mother had put rupees 1000 into your money box on your first birthday and rupees 100 on each birthday hereafter. What was the amount in your money box on 5th birthday? To find this, let's find amount on 2nd birthday. What was the amount in money box on 2nd birthday? Yes, it was 1100. So, we can write it as the amount on 2nd birthday is equal to rupees 1000 plus 100 and that is equal to 1100. Similarly, we can find the amount on 3rd, 4th and 5th birthday by adding rupees 100 to the amount on the previous birthday. So, amount on 3rd birthday is equal to rupees 1000 plus 100 plus 100 and that is equal to rupees 1000 plus 2 into 100. And we can write it as rupees 1000 plus 3 minus 1 into 100. Why are we writing it as 3 minus 1 into 100? Yes, as we are calculating on 3rd birthday. So, what is the amount on 3rd birthday? Yes, it is rupees 1200. Similarly, amount on 4th birthday is equal to rupees 1000 plus 100 plus 100 plus 100 and that is equal to rupees 1000 plus 3 into 100 and we can write it as rupees 1000 plus 4 minus 1 into 100 and that is equal to rupees 1300. Amount on 5th birthday is equal to rupees 1000 plus 100 plus 100 plus 100 plus 100 and that is equal to rupees 1000 plus 4 into 100 and we can write it as rupees 1000 plus 5 minus 1 into 100 for 5th birthday and that is equal to rupees 1400. Observe the list of the numbers here: 1000, 1100, 1200, 1300, 1400 and so on. Are these numbers in AP? Yes, as the difference between the two consecutive terms is 100. Now looking at the pattern above, can you find the amount in your box on your 6th birthday, on your 14th birthday or on your 30th birthday? So we can write it as the amount on 14th birthday is equal to amount on 13th birthday plus rupees 100, and that is equal to rupees 1000 plus 100 plus 100 plus 100 up to 12 times plus rupees 100, and that is equal to rupees 1000 plus 13 into 100, and we can write it as rupees 1000 plus 14 minus 1 into 100. Why have we written 14 minus 1 into 100 here? Yes, you are right, because we are calculating for the 14th birthday. In the same way, the amount on your 30th birthday would be rupees 1000 plus 30 minus 1 into 100. So you have observed that the 14th and 30th term of the sequence formed here is rupees 1000 plus 14 minus 1 into 100 and rupees 1000 plus 30 minus 1 into 100 respectively. Now, how can we find nth term of an AP? Let's take A1, A2, A3, A4 up to A and B and AP, whose first term A1 is A and common difference is D. So, what is the second term of this AP according to the general form of AP? Yes, you are right. The second term A2 is equal to A1 plus D, and that is equal to A plus D, which can be written as A plus 2 minus 1 into D. 2 minus 1 is for the second term. Similarly, third term A3 is equal to A2 plus D, and that is equal to A plus D plus D is equal to A plus 2D, which can be written as A plus 3 minus 1 into D. Fourth term A4 is equal to A3 plus D, and that is equal to A plus 2D plus D is equal to A plus 3D, and we can write it as A plus 4 minus 1 into D. So, what would be the nth term of the AP? Yes, AN is equal to AN minus 1 plus D, and that is equal to A plus n minus 2 into D plus D, which is equal to A plus n minus 1 into D. Here A is the first term and D is the common difference. AN is called the nth term of the AP, and it is equal to A plus n minus 1 into D. Let's consider a few examples where we will use this concept to find a given term of the AP. Remember the example mentioned earlier? So, using this formula, can you find the amount of money in your box on your 35th birthday? Let's try it. What is A here? It is rupees 1000. What is D? Yes, it is rupees 100. And what is N here? N is 35. So, using the formula AN is equal to A plus N minus 1 into D, we get A35 is equal to A plus 35 minus 1 into D. That makes it A plus 34 into D, and by putting the values we get rupees 1000 plus 34 into 100, and that makes it rupees 4400. Find the 10th term of the AP 2, 7, 12 and so on. What is A, D and N here? A is equal to 2, D is equal to 7 minus 2 and that is equal to 5, and N is equal to 10. As AN is equal to A plus N minus 1 into D, therefore A10 is equal to A plus 10 minus 1 into D, that is equal to A plus 9D, and that is equal to 2 plus 9 into 5, which makes it 47. So, 10th term of the AP is 47. Our next example is which term of the AP 21, 18, 15 and so on is minus 81. Also find that is any term 0 here? Here we are asked to find which term of the AP is minus 81. That means we are given AN here instead of N. So, what are we supposed to find here? We are supposed to find N. So, what is A and D here? A is equal to 21, D is equal to 18 minus 21 and that is equal to minus 3, and as you know AN is equal to minus 81 here. Using A plus N minus 1 into D is equal to AN, we get 21 plus N minus 1 into minus 3 is equal to minus 81, and that is 21 minus 3N plus 3 is equal to minus 81. So, 24 minus 3N is equal to minus 81. 3N is equal to 105 and that makes N is equal to 35. Now, in the second part of the problem, we have to check whether for any value of N, AN is equal to 0. So, by equating A plus N minus 1 into D to 0, we get A plus N minus 1 into D is equal to 0, and by putting the values of A and D, we get 21 plus N minus 1 into minus 3 is equal to 0, 21 minus 3N plus 3 is equal to 0, that makes 3N equals 24 and N is equal to 8. Therefore, 8th term of the AP is 0. I hope you enjoyed exploring the general form and nth term of the AP. Remember, A plus D, A plus 2D, A plus 3D and so on is the general form of the AP, and A plus N minus 1 into D is the nth term of the AP. Here are few problems for you to try by yourselves. First problem is, write first 4 terms of the AP when the first term A and the common difference D are given below. In first case, A is equal to 10 and D is equal to 10. And in the second case, A is equal to minus 1.25 and D is equal to minus 0.25. The next question, which of the following are AP? If they form an AP, find the common difference D. First sequence is 2, 4, 8, 16 and so on. Second sequence is 0.2, 0.22, 0.222 and so on. Here is the third question. Fill in the blanks in the following table given that A is the first term, D the common difference and AN the nth term of the AP. In the first case, A is 7, D is 3, N is 8 and we have to find AN. In the second case, A is minus 18 and D is missing, N is 10 and AN is 0. In the third case, we have to find the first term when we are given D as minus 3, N 18 and AN minus 5. Before we take a break, let's recapitulate the main points of the today's session. The general form of an AP is A plus D, A plus 2D, A plus 3D and so on. In general, for an AP, we have D is equal to AK plus 1 minus AK, where AK plus 1 and AK are the K plus 1th and the kth terms respectively. A given list of numbers A1, A2, A3 and so on is an AP if the difference A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 and so on gives the same value. In an AP with first term A and common difference D, the nth term is given by AN is equal to A plus N minus 1 into D. I hope today's journey was fun for you. Let's make a halt here. In the next session, we will revisit these destinations once again to solve few more problems on this concept. Till then, have a nice time. Goodbye.